This is the solution for day 2 of Advent of Code 2022. So today we're playing rock, paper, scissors, and we're being given some input that tells us what the other person's going to play and what we should play. So we get given ABC, which is rock, paper, scissors, respectively, and we also get given XYZ, also rock, paper, scissors. So we get a score of 0 if we lose, 3 if we draw, and 6 if we win. And then we get an extra score of 1 for rock, 2 for paper, 3 for scissors. So the first thing we're going to do is have a look at the straightforward solution, where we just write down all the possible options for a round, for what they can play, what we can play, and the scores, and just calculate the outcome that way, calculate like our total score. And then we'll look at a more interesting solution after that. This is a first pass solution, where we just load up the input, we run through the lines, we calculate a score for each line, and then we sum up the scores to get our total, which is the answer to part 1. And the way we're calculating scores is to take every possible combination of what the other player played and what we're going to play, and figure out the score manually for each of them. So for example, this first case, we've got A and X, which is rock and rock. So that's a draw, and then we get 1 bonus point for playing rock. But once we've done this, we can see that our scores come out as a sequence of numbers from 1 to 9. So there should be a way to calculate this rather than having to write it out directly. So if we sort these by their score value, and then assign numbers to each of our letters, so A, B, and C become 1, 2, and 3, X, Y, and Z also become 1, 2, and 3, then we can start to see a pattern that we can work with here. So looking at the first values, we get a difference of -1 when we're working with losses, apart from one case, and we'll come back to that. Then for draws, we get a difference of 0, and for wins, we get a difference of 1, apart from an outlier case. So these two outlier cases, these are caused by rock having a value of 1, scissors having a value of 3, but rock beats scissors. So you have this like wraparound effect at the end of the comparison. So we have to deal with those as special cases, but otherwise we have a way forward to turn this into a function that'll let us calculate this. So let's have a go at that. Let's start by changing how we load up our data. So we'll copy this data loading, and we'll modify the map. So we'll transform this data as we load the lines. So we'll start by turning that line into a line variable, and then we want to split up the symbols into 2 pieces by splitting on space. So line.split on white space, and that will give us back an iterator over all the values that it found. And then we can extract values from that iterator by calling next, unwrapping, and then that will give us back a single character. So we want to turn that into a number, so we'll grab its byte value, and then to normalize it down to 0, 1, 2, we'll subtract off the byte value of A. And then to make this easier to work with, because we're going to want to work with negative numbers, we're going to convert this into an I8. It will be a U8 by default, an unsigned number, which is correct, but for our purposes, negative numbers are helpful, and we know that we're not going to go out of range, so we'll get away with it. And then we want to do the same thing for the hour value, and just subtract off X, which is the minimum value for that. Cool. So with that, we can then define ourselves a win multiplier. So looking at these 0, 3, 6, if we could get this to be, or get back the numbers 1, 2, and 3, depending on which situation we're in, that would give us an easy way to calculate that value. So fun win multiplier, and that will take their value as an I8, our value as an I8, and return an I8. Okay, so this we will do by computing a diff first between the two values. So we'll subtract their value from our value, which is taking the 3 away from the 2 away from the 1, so we'll get the -1 in that first case. And then to handle our special cases, where we've got a difference of 2, we'll use a match. So if we go for match on diff, if we get back a +2, which is this first case here, we want a -1 as the result. And if we get back the opposite, which is -2, we want a +1 as the result. And otherwise, we can just use the diff. And then to turn this into a multiplier, this will give us back -1, 0, 1. We want 0, 1, 2, so we can add 1 to that value. So that calculates what we need for this first piece. Then we can calculate the overall score. So we'll just define a new score function, just score alt for now, and that'll take the same parameters. Let's just copy that. And then it'll return an I32, because the sum can certainly go outside the range of a U8 or I8. Then we can do win multiplier of theirs and ours times 3. So that gives us our 0, 3, and 6 values for lose, win, draw. Then we want to add on the score for whatever we played. So that'll be ours plus 1. So we've got values 0, 1, 2, but we get scores 1, 2, 3 for playing the different hands, and then as I32. There we go. So now we can do the final bit, which is just calculate our sum. So we'll iterate through plays, and then we need to call this slightly differently. So that'll be theirs, ours, and we'll pass that to score alt with theirs and ours, and those will need to be dereferenced. They'll come through as references from the iterator. And then lastly, we can print out our new solution. Let's check if that works. So let's check that builds. And it looks like we've made a mistake. So it's complaining about expecting a string to be passed in. So it's expecting string values in the plays iterator. And it's complaining about the collect as well. So we've made a type mistake somewhere. Let's get back and check that out. And that's just here. The dangers of copying and pasting. That's why we shouldn't do it. That should be a tuple of 2 I8s. So that'll fix that. Let's give that another run. Let's check that builds now. Good, it does. So let's run it and see what we get. Excellent. We're getting the same value as we were for the simple solution. So our new solution works. Let's move on to part 2. So in part 2, we change up the meaning of X, Y, and Z. So rather than meaning rock, paper, scissors, X now means try and lose, Y means try and draw, and Z means we need to win. So that changes the logic slightly. We've now got to calculate what we should play rather than being told, and then calculate the score. So let's have a look at the simple solution for that, and then, same as last time, we'll do a more complicated solution that hopefully is a little bit less code. Here's our pick play function that takes inputs as instructions, and then outputs an actual play to make. So the meaning of X, Y, and Z on the way in and way out is slightly different here. So on the way in, for example, on this first one, they're going to play rock. X means we're trying to lose. That means we play scissors. So we could just take the output of this, map it through our score function from the first version of the part 1, and we'd be done. But looking at this, we can see a pattern. So if we look at the B case, so when they're playing paper, we output X, Y, Z, and then looking at the A case, when they're playing rock, we output Z, X, Y, which is a rotation of X, Y, Z. So we're outputting X and Y shifted down 1, and then the Z has rotated round, gone to the front. And then same with this last one. So you can either think of this as a rotation forward by 2 or a rotation backwards by 1. But either way, you've got Y, Z, and then X is at the bottom. So we've either gone forwards by 2 or back by 1. So bearing that in mind, how could we code this up so that we get this as a nice function rather than as something we have to hard code? Let's start defining a function called pickPlayAlt. And that's going to want a similar signature to a previous method. So let's just copy our 2 I8 inputs. And then we'll return a tuple of 2 I8s. So the values that should get played. So the first thing we want to do is return the theirs value. That's not going to change. We just need to know what it is. So the theirs value determines which of these 3 situations we're in. So let's match on that. So if we're in the first case where we've got a 0, then we want to rotate forwards by 1 spot. And the way to do that would be to add 2. So to go from X to Z, that's a jump of 2. So we'll do ours plus 2. And then to correct for the overflow, so going from Y to X, that is 1 plus 2 takes us to 3. But we want to get a value of 0. So that would be a modulo 3. And that works for the last one as well. So taking 3, adding 2 to it, that gives us 5. And then modulo 3, that gives us back a 2. Then for the middle one, we don't need to do anything. Everything will stay the same. And then for the C, the 2, we'll output ours plus 1, modulo 3. Same kind of logic. And then finally, for the leave it alone case for the draws, we'll just leave it alone and output hours value. So let's now use that to calculate our stage 2 solution. So we want to call pick play. I've just copy pasted the basic solution, and we want to pass in something like this to be able to call the pick play. Alt, and that'll be theirs, ours, and then we can tidy up this bit as well by copying from here to map through score alt instead. And we don't need pointers here or dereferences. Okay, let's give that a test. So let's cargo run that and see what we get. Good, so for stage 2, both of our solutions give us the same value. So did we make it better by making it complicated and getting into the details with bytes and rotations and things like that? Maybe, maybe not. Certainly is harder to understand what we've done the second time, but it was much more satisfying and feels like a much better solution to the problem we were set. So I hope you enjoyed it as much as I did, and I will see you tomorrow for the next one.